Okay, so we should be streaming right now. So I don't know, you can see it on the left of your screen that this is live. So we are now live. Okay.
Okay.
Okay, so here we are. And actually what I'm seeing is the people that is talking, that's me, is the one that appears on the right corner of the transmission, the webcast.
Okay.
Okay.
Good.
Okay. So then we are all ready to get started whenever you want. Let me know. I do the introduction and then we get it going.
Keep going. We
Okay,
can go.
so good morning, good afternoon, good evening, or wherever you are. So this is Roberto Lopez, the General Chair of SPLC. Welcome to this nice tutorial from one of your sponsors, Pure Systems. So it's about 30 minutes. Also welcome to the people that is watching in your YouTube channel. If you have any questions, you can post them. I will translate it, pass them to Zoom. Okay, so we'll get started. Thank you very much, for, Danilo and Robert, and off you go.
Yeah, so thank you for the nice introduction. Yeah, I also want to welcome everyone from our side. So my name is Robert Hellebrand. I'm lead field application engineer at Pure Systems, usually taking care of showing new customers our products, our solutions, explaining our consulting services, and so on. Today, I'm happy to be co-moderator for this presentation, together with the main presenter being Danilo Beucher. Danilo.
Yes, same to everyone. Good morning, good afternoon, whatever. My name is Danilo. I am CEO and co-founder of Pure Systems, and happy to have that presentation here virtually to share our thoughts on modern product line engineering with you. So I have a question. You can see the presentation slides. Just need to confirmation for that.
Yes.
Yes.
Yeah.
Yes.
Okay, then off we go. We would like to talk to you about modern product line engineering. And as you can see from the title, this is actually part one. In the preparation of that talk, we figured out that we want to split this into multiple parts. We come to that a bit later. So this presentation will talk about our views on product line engineering today in an industry in terms of opportunities and challenges we have. Both are there these days. And it is based on our experiences working in the field of product line engineering for more than 2 decades. We take a look at product line engineering a bit from a higher level perspective than you usually would see at SPLC, but I think it would help us to understand where we should be heading. And it's also kind of an reference to the panel which we will have later on in the SPLC. So let's get on with this one. So for those who have not heard yet about Pure Systems, which there are a couple on this planet, let's talk about us very briefly. So we have been developing and selling a tool for product line engineering for almost 16 years now. So we have kind of experience in this area. From the tool side, we cover with this tool a lot of different engineering disciplines in the area where product line engineering is mostly used. This is where companies develop systems with software and hardware combined. So you can see there's a couple of tools we integrate with, but this is complemented with this consultancy telling our customers how to do this properly. And what we will do here is, as I said, look at this, all of this, what we have learned, and try to put it into perspective and see what kind of new opportunities we have and what challenges we can address today with product line engineering. So yes, what is modern product line engineering? That is a question. Why do we say modern? So we think that the modern product line engineering is actually something which you really don't cannot separate from other engineering activities. It is something where everyone in the engineering is involved, benefits from it, and contributes to it. As we learned, variability cannot be isolated. It is everywhere, and it happens all the time. So that it's not a single spot where you would can locate this one. So this is what we have learned. It is everywhere. It's fully woven, as we say it, in the engineering fabric of your approaches. But still, you can clearly see it. You can see, and you have to be able to see it from the perspective of variability, variations, how it's being used. It's a very, very clear, separate perspective. If you don't do this, it's not working. So I think this is in a really nutshell what we see how product line engineering is connected to the engineering as such. Maybe one observation, which we won't talk much about, but variability, as we see it, has moved over the couple of years to be resolved later and later in the process of product engineering and manufacturing. Just from early compile time, for instance, in software, to as late as possible. But let's take a look at an example which helps us to get through the presentation. So we have here basically a small system which represents a product line, and as you can see, it's built identified by the colors from different, basically from different domains. We have mechanical, we have electrical data and parts. We have software, and we also have a part which actually is a combination of all of these and is supplied by someone else. So it's not developed in-house. That is quite important. We will come back to this one later. So this is how you could break down, let's say, the architecture of a typical product line based system if you look at it from a building block perspective. So what we also learned, that is obvious, even in product lines, there is no such thing as a waterfall. It is always constant change. It happens over a long period of time. You have to react to change. You will do changing to the building blocks and so forth to deliver this one. So this is very important. That's a challenge we have to address. And let me show you a brief example what this real world stuff is today. So that is the news from yesterday. It's German for those who can't read that one. That is not English, that's German. And yesterday, BMW announced that they will update their 750,000 cars, devices, IoT devices, whatever you call it, cars, over the air with their newest software, so that they will get a better experience. This is the reality today. So even for such a interesting and complicated system like a car, you would do now over-the-air updates, shipping software out in thousands and thousands. There's a bit more to this one. You can go to the website and read it, or let it get it translated. But just this is an example of what we are talking about here. And what are important topics? And we will not address all of them today. That's too much, but these are the main things we have seen. So there is integration of all of these building blocks in a safe and working way. We have the scalability of the thing. Product lines are more complex than single products to a certain extent. We will address that also later. Collecting feedback from the instances is an important thing, meaning that once your product is shipped to the user, like the individual car, how do we know how it behaves in the field and how we react to this data? That is one topic we'll be talking about, and then supply chain management, building blocks, supply chains in product line engineering, and the other topics. Very interesting one, very challenging one. Maybe we will do a part 3 where we talk about these in more detail, and we have to skip them for today. Let us look at one of those things which is really kind of the main thing in engineering. That is, in order to engineer something, you will change an asset. Meaning you add something, you remove something, you fix an issue, whatnot. And the question is, when you do this, well, what is the impact of this one? How can I make sure that what I do is leading to a proper working system? And that is not something specific to product line engineering. That happens anytime in any kind of product. It should happen at least that you worry about this one. Given that most of the product lines we have seen so far are rather in the safety critical domain, it is more important to worry about this. So, and what the only way to do this properly as of today, to verify that in the end a thing is working as intended, you will have to integrate this change into the overall system, and then do validation and verification for this one, and see if this meets your the expected outcome. Of course, you can sometimes take a shortcut, but in the end, for many changes, there is no other way than to integrate this, see what it does, and then kind of ship it downstream to the deployment or wherever it goes. So this is a typical thing which is not specific to product lines. What is specific to product lines is that there is, at the moment, we don't see any approach which does that for a product line as a whole. So which means you have to run this for each of your instances. What is helping us here is that we now have data in a digital form for all of these engineering disciplines I have shown you previously. Even down to the mechanical one, a lot of the engineering now happens in the digital domain as opposed to a physical domain. So you have simulations, everything is engineered digital, and a lot of the validation verification can happen electronically. So this is one of the things where we can achieve a huge benefit for product lines compared to what we had before. And we have the software came up with a term called continuous integration. With everything digital, we can actually run continuous integration on everything. So that's great. So this is a great opportunity to speed up engineering. Unfortunately, as I mentioned, we have that scalability issue, meaning that if we really want to do it for a product line scenario, we have to do it for multiple instances, multiple times. So if a single validation of a single derived product takes 1 minute, if we have to go through like 100 variants, it takes 100 minutes to get the answer if we do it sequentially. If we have 1,000, it takes 1,000 minutes. You see the picture. It gets longer and longer, and that is a problem. And of course, well, there is a solution to that, and it's readily available. If you would put out like a machine big enough to cover 1,000 variants, that can be very expensive. But with the help of the concept of an elastic cloud, we have ways now to get a computer which is 10,000 times or 1,000 times faster than your normal one for just a minute. And that means even if we have 1,000 or 100 variant, we don't care. We basically get the result in the time it takes roughly to validate a single variant, if we can do all of this electronically. And that is a huge opportunity for us to scale our product lines and get much better results for consistency checking and all of these things, without having to advance in that validation and verification of whole product line, which is mathematically a big challenge. So what is the main takeaway of this slide? Well, the current technology and all of these buzzwords, well, it's 3 main buzzwords here on that slide. That is new for me, but this is really something which is very exciting to use. And if we can use all the existing infrastructures to make product line engineering much nicer, much faster, and much more responsive, which is one of the great things of these technologies. So that's one thing I'm really excited about today. And let's go on to the next topic, and that is will also bring us to a main buzzword, which I have not thought yet to put on a slide, but you will see it. Why this is really a good thing. Anyway, we have upstream feedback. What does it mean when we talk about upstream feedback? Well, we have a product instance that is, as I said, the car which runs. So where the final delivery of the product line instance has been deployed. And these days, a car or whatever you have, even a small like thermostat, can talk back to its makers if we want this. If we assume that the concerns about privacy and security are handled properly, this opens great opportunities for engineering and business steering alike, right? We know that, we have heard about this one. But what is again the specifics for product line engineering, which we can exploit here and which we can take benefit of? So this is one instance, right? In product, we just saw that there is 700,000 BMWs getting the new software, and they are not all identical. In fact, they are most likely very different. And that means we have many product instances, and only a couple of them are identical to each other. They all run basically stuff from the same or use the same product line as its origin. And if we go back and try to integrate this in a, let's say, simple way, the data, and put this together, we would not detect that there are specific combinations of features or variability configurations which make more problems or perform better than others. So if we take this into account, though, we can get really interesting knowledge out of this one. And the amount of data is so huge that we really should care about machine learning, artificial intelligence, whatever you call it, because that can help us to get through this data and basically let us see things which we can't see because it's too much data here, actually. So this is also a great opportunity for product line engineering, which is partially also already exploited, but which really should become more relevant and more of our focus these days. So that's number two. Last but not least, number three, I would like to go through is the concept of supply chains. So I didn't invent that. Hermann Hartmann, some of you may know him, talked about this in his dissertation based on his experiences with some semiconductor manufacturers and others in product where they looked at product line engineering. But I think this is really an important stuff to look at. In the real world, there's not a single maker of a product line. You will combine building blocks from different sources into this one. So let's have a look at what the specific opportunities and kind of challenges we have here in modern product line engineering. So this is a view on our sub product line, which we integrated, our sub building or our building block, which we integrated into our main product line. And if you remember, that was made by someone else. So let's draw that picture. So we have the product line on the left. That is the one the maker of these sensors uses to deliver a product, the sensor, which is used in that other product line that we call a downstream product line, as a building block. So this is a product, it's configured, it's used here, right? That is one way. So it's a traditional instance from a product line. It is integrated here as a building block to a higher level product line. So that's typical stuff which has been around for a while. But in many cases, you have also different needs where it's not just a single product you want. You want to have the flexibility of the product line delivered to someone else. So if we do this, we could take the whole product line, and that is also happening. We see the product line as the building block and integrate this. This is often happening in-house engineering. So you get the full product line with all the complexity of it. So it's great because you get really a lot for it. You have to configure it though. Well, that is an approach. But in many cases, we learned that something in the middle is really what is of interest, and that is a product line which is a product line. It is configurable, but it's not fully configurable, meaning that a downstream subset of the product line is created and then shipped as a building block. And there is not a, if you look at this one, so you can do this multiple times, obviously, with different configurations of the product line subset. Not all of the functionality of the main product line is in there. And if you remember, a product line consists of mechanical data, electronics, software, everything. And it should really be reduced to what is necessary for this step. And the complexity of the whole product line is left behind here in this step where we go from the product line to the product line subset. Yes, with that, so we have these 3 approaches, and all of them are used and are of interest. So modern product line engineering should be able to deliver any of these approaches as needed for the downstream product line and not focus on one or the other. There is a couple of challenges embedded in this one. One I would like to highlight is the fact that we cross, when we go into that gray downstream product line, we may cross a border of tooling and whatnot. That means we have to convey the data for variability, just like any other data, in a way that the downstream product line can consume it. And this is where standards for data exchange can be very helpful. And some of you may know that this is an active area of development. It's new. So like 5 years ago, there was almost no standard which talked about this one. These days, we already have something like this in AUTOSAR. We have the OASIS working on the variability exchange language for exactly that purpose. We have the OMG with SysML v2, which integrates variability concepts which are meant to be integrated in an open way. We have also other standards, by the way, which not talking on the data level, but like ISO 26580, which is more about the overall picture of this one. So standards are actually something which shows us that modern product line engineering has arrived in mainstream. We have enough knowledge to build these kind of things. However, we know that standards only work if they are actually being used. And at the moment, all of these things are in the making and have not a widespread use. So we will have some work ahead of us to do this. That is an opportunity and a challenge in itself, both. So looking at this one, finally, we have these scenarios. We have to work on this to make it more easy to do this. But all of this is happening right now in modern product lines. Especially the one where we talk about product line subsets is of interest in many areas to reduce data transmitted to the next level. So to conclude this really brief walkthrough to only a few points which we see in modern product line engineering, I would like to come back to the challenges or kind of main problems, it's not the right word. The main topics I have talked about, that is the integration of all of these building blocks into something useful, considering the changes. The scalability product lines are more complex and require a bigger scalability of the infrastructure and the approaches than normal product engineering. If you would consider a single instance as the one. Of course, you have also products which are itself actually a product line, but don't call it this way. So we have the feedback thing, which we should take more benefit from, also in our engineering, and we have to find out how to do that properly, and the supply chain management as well. And the buzzwords on the right side, all of these things are, is talked about these days, and they actually will be helpful for us to accomplish this one, or are actively being used to accomplish this right now. So I think, I know it was a rough ride for all of us through this one. So please, if you have any questions, well, you can, of course, if you want, ask them now. We also have a panel after this one where you may also ask questions, but I would like to hand over to Robert to tell us how we go on from this one.
Yeah, thank you, Danilo. Well, today you heard here about the modern product line engineering as we at Pure Systems see it. You heard about the challenges that we see here, but also about the opportunities that we see here with the given technologies at hand that we can make use of to tackle those challenges. In our upcoming second part of this presentation, and Danilo, you might have a slide for this.
Oh yes, sorry. I was
no problem. Yeah, which we scheduled for the 11th of November, 10 o'clock Central European Time. You can learn more about what more precisely what Pure Systems as leading product line engineering tool provides in capabilities already to tackle these challenges with some examples, and also get some information about how we plan to approach additional challenges where we see that, or some of the challenges that we heard of today, where we see that there's more potential that we can better cover them with our solutions. And you will also learn a little bit about the offerings around the tool Pure Variants, in form of services by the Pure Systems experts, how we can support you tackling these challenges that we heard about today. Yeah, and by the way, here you see it, you can find also the registration link that was just shown on the earlier slide on our webcast page. So if you go to puresystems.com in the webcast subpage, you will see all the current scheduled events, including the one I mentioned at the moment right now. And yeah, finally, I want to talk about also our already available material on YouTube. If you search for Pure Systems on YouTube, you will find our channel that provides access to videos that cover the basics about product line engineering and about how to make use of Pure Variants to solve your challenges in that area, as well as advanced topics. And you will also find, I think, the recording of today's session there in a few hours or in 1 or 2 days. So yeah, hope to see you again in a second session. With that, I say thank you and bye-bye.
Yes, so I also say thank you to you. And as we have been asked by the organizers to really end this session 8:30 Montreal time sharp, we will do so. So we won't go into questions. Sorry about that, but we are not out of this world. So please get in touch with us. And thank you for Roberto and for the SBLC team to host our session here that nicely.
Okay, yeah, very good. Thank you very much, Danilo and Robert. Everybody can follow, get in touch through WOVA, set up a meeting if you want with these guys to talk during the conference, if not afterwards. And thank you so much for your participation. So we really have to rush to get things started for the panel in 30 minutes. We hope to see you there. Okay, thank you very much and see you in a few minutes then. Bye-bye.
Bye-bye.
Bye.